everyone. My name is Camden Miner,
And I'm Keaton Miner.
and we are with Helix Labs. And in this podcast, we're going to be breaking down AI topics and news to keep you informed and ahead of the curve. So, in today's episode, we're going to be talking about Nvidia's big announcement that they are going to be manufacturing in the US for the first time. Keith, if you want to go ahead and talk about where and what they're doing.
Yeah, so they made a big fancy announcement, a little bit maybe a little bit hypey, saying that they're going to manufacture their AI supercomputers, which basically means they're going to put together all their GPUs into the nice racks and clusters that they sell and ship to the companies. But basically, they're going to be doing this, I think, did it say Arizona, Texas, is where they're
Arizona
gonna be
and
manufacturing.
Texas, yeah.
And it was a massive investment. It was like, what was it, $500 billion on the original that eventually we're gonna put into it, or that did they say? I don't remember if they said in their final announcement, but they're gonna be investing a significant amount of money into bringing their stuff here, and it makes sense because I mean, obviously there's a tariff situation, but then there's also sort of Taiwan Taiwan political
Yeah.
situation. So they need to hedge their bets a little bit and bring their stuff here. Um, but that's just a sort of mini um, refresher, is that Nvidia is the one who designs the chips, and then TSMC is typically their manufacturer, their chip manufacturer. So they do the actual like lithography, so the really super high resolution stuff. But then Nvidia brings them back and puts all their chips into these into essentially these what superclusters, which is I guess what they're calling their AI supercomputers, and then they sell those clusters to uh, big companies who then trade massive models like OpenAI uh, or Anthropic, Meta. All of them, they have tons and tons of these racks of what at the time right now they have tons and tons of H100 of racks of H100s, all linked together, and soon, I guess the Blackwell is the sort of new architecture, the GB100, GB, or the B100, B200, and the GB200 is their new sort of flagship GPUs right now.
Yeah, so in these new manufacturing facilities, they're going to be making those Blackwell chips, like Keith talked about. And by Blackwell, that is the GPU architecture. So basically, the family of chips. So how it works is you have your Blackwells, your generation of chips, and then inside that you have different chips like the B100, which is a GPU, the B200, which is a GPU, and then those come together to make a rack. So Nvidia shows on their website the DGX B200, which is actually 8 B200s, strung together. And they say it delivers 3 times the training performance and 15 times the inference performance. So basically, answering a question and response from a user on like a chat bot. 3 times the training, 15 times the inference compared to the H100s, which is what everybody's using right now.
That's interesting. I actually saw. So, I mean, one of the what keeps NVIDIA ahead so far ahead is their CUDA software layer that all the developers interact with on those chips, and then makes it a lot easier to run things. Well, supposedly it's still kind of a pain to actually uh, get things running for the first time, but I'm sure it's a lot easier than using like Intel. But the just as an example, like that DGX, was it's 8 200s sort of
Yeah.
linked together in a cluster. Well, they go up to like an NV72. They can have clusters of 72, I
Wow.
believe. Their biggest, and these run. I don't even know how much that runs up into. It's like probably $2 million easily to get that kind of rack But big companies are willing to pay for that if it's got 15 times the inference speed as compared to the H100s, whatever their relative the relatively similar rack, I guess. Um, then that's really worth it, because like think about AI right now. You when you have a model, you have the training, which takes a lot more GPUs to actually train a model, just because of all the actually all the you have to store all the weights in memory and update those and have all of the massive amounts of data, training data that you're processing. It's a crazy amount of compute. But then you go down a step, kind of like we talked last time, where inference, it costs a lot less compute, but in the end, the inference comes the most valuable part, because that's what, when we are on ChatGPT and we're asking a question, the model is inferencing. And because there's so many users on top of these, they need to have many GPU clusters that are running inference. And it ends up being a lot more than what's needed for the training, especially if you have a ton of users. So a lot of people think that inference is going to become the main, or probably the main buying factor for a lot of these new chip designs, especially as the reasoning models take off. Because what the reasoning models is doing is essentially just increasing the inference time. It's like, if you actually see how the O3 is working under the hood, it's reasoning, and quote unquote, but it's actually just, writing a much longer response and like making itself go through until it gives a final response. So it's thinking, but that's just inferencing. It's like extra tokens basically. So inference is gonna be the hot spot where everyone's gonna go, and I'm sure Nvidia is keeping that in mind when they're designing their chips.
Okay, so back onto the topic of NVIDIA's new manufacturing facilities. Who are their manufacturers?
TSMC is the main guys. They're the ones that do like the hardcore lithography. But then, that article kind of hits on some others. I think it says Foxconn, Wistron. What's that? Say? Amcor and Spiel. I don't know what the last three companies, but Foxconn's the ones that do the iPhones, essentially, the Chinese manufacturing company. So they're good, of course. Um, but TSMC is definitely the ones that are doing the really extreme stuff with the lithography.
Yeah, yeah. So um, this AI announcement is huge for the AI industry, but also really affects the power industry and the power distribution system of the U.S. because you have these AI factories that have tons of these racks and GPUs inside of them, and all of those consume electricity. And they've coined these terms as like gigawatt AI factories. And just for reference, a gigawatt is 1 billion watts. And another reference is 1,000. It's 1,214 watts to power a home, and so it's just an outrageous amount of power that is going to these GPUs. And so there are companies like nuclear companies that are starting to spin up reactors. I think Amazon recently partnered with a nuclear facility. Do you know anything about that?
Yeah, I think it was Talon Energy, but I'm not 100% sure on that. But basically, they're like, we're gonna put our data center right next to this what was decommissioned nuclear facility and now is being recommissioned. And I think the intent is to just, power their data center.
And I think there's lots of big
Why?
announcements too. With I think lots of coal facilities are coming back online to kind of push the U.S. in the direction of being on top of AI to power these big gigawatt facilities.
Yeah, I mean, usually with some of the oil and gas. I wonder what they think about all this.
They're excited. I mean, it is a big announcement. The problem is how quickly can you get facilities online? Because building whole reactors or power plants takes a lot of time. So that's why they're kind of shifting to coal. Is because over the past, I don't know, 10 years, we've kind of shifted from using coal, and so coal plants have been decommissioned. You still have the components in the power plant. You still have the stack and all those things, but they've just stopped using them and they've put in natural gas units. And so what they're doing is they're trying to bring those coal units back online to then supply for now and then build up better facilities, is what I assume, for natural gas or uh, nuclear and things like that.
Makes sense.
Cool. So what really are GPUs? I know it's a term everybody throws around with these, and I like to start with a fact from Three Blue One Brown. He's a YouTuber I really enjoy watching, and the way he explains it is he says, um, let's say you could do 1 billion additions and multiplications every second. Um, how long would it take you to do all the operations needed to train some of the largest LLMs out there? And I think he based this off of GPT-3. And according to him, it would take around 100 million years to do this. Line by line, doing every single operation that it takes to train that model, which is outrageous. And how is that even possible? And that's really where GPUs come in. GPUs are special computer chips which are really optimized to do those operations in parallel. So rather than one single operation, it breaks those all down to go all at once. So they all happen at the same time. And in the case of Blackwell GPUs, these are really specially tuned for transformer models. And an example they have is a cutting edge model with 1.8 trillion parameters would have taken 8,000 Nvidia H100s, so the previous architecture, running at 15 megawatts of power, and Blackwell chips can do that same work, only needing 2,000 GPUs at 4 megawatts. So, outstanding performance if it's true what they're saying.
Yeah, that is actually pretty insane. Um, and the craziest part is I believe, I mean, it was leaked that the like GPT 4.5 was trained on like a cluster of 20,000 GPUs. I think H100s, I don't know for sure, but um, yeah, when you can become that much more efficient through the Blackwell architecture, like you don't have to buy nearly as many B100s or B200s to get that level of performance.
Yeah. I actually have it written down. For GPT-4, it took them 80. That they've said that they've spent 80 to 100 million just to train GPT-4 off of that old architecture. So, you know,
Crazy.
now with the Blackwells, it's going to be pretty crazy.
Yeah. Yeah. I wonder if the GPT-4 was done with A100s or H100s because these things are changing so fast, and like it feels like we're always delayed of probably several months at least on what the labs are running and training compared to what we actually see. And yeah, I'm just curious if it would be if the which architecture they used for those. Oh yeah, it says right there on your thing that there was about 25,000 A100s.
A100s, yeah.
Yeah,
They're
that's
running in
pretty
parallel
crazy.
for 90 days. So, I
I
mean,
wonder
that's a.
who
What are you
I
going
wonder
to
who
say?
leaked that. I wonder who leaked that. If that was, I bet that was not supposed to come out.
Maybe it's just estimates, like how they estimate
Yeah.
what the parameters are on those models.
Yeah, that makes sense.
So we can
Um,
kind of hit on, you know, how GPUs could be beneficial for your business. And that really ties into running your own AI models and how that can be beneficial for you if you want to talk about that.
yeah, I mean, I guess there's always like a battle, especially with businesses on privacy. Do you want to outsource to the big model companies like OpenAI or run your own models? And a lot of people want to run their own models, but you have to buy the GPUs to run inference on those models. So like you, what did we discuss last time? We were talking about the Llama 4 and how many um, roughly H100s it would take to run the huge behemoth model. I forgot what it was how big it was, but I think it was like 16 H100s. But essentially, if you want to if you want complete privacy, you would want to run the models on your own GPUs, which essentially you would probably start with buying a cluster. Most people are, I would guess, buying A100s with about 80 gigabytes of VRAM, and then you can link. They'll be linked if you buy a cluster. I think you'll get usually between 4 and 8 in a cluster, and so that's plenty of VRAM to run basically any uh, model. Um, at least any open source model today. But I think the big debate is always on the privacy, and you can buy those GPUs, or you could even, I guess, AWS and a lot of these cloud servers, like Lambda Labs, are also serving GPUs for you to be able to run for your business. But um, I guess it takes an extra level of bringing those GPUs or instances into your own VPC, which is a whole nother uh, layer of cybersecurity we probably don't want to get into right now.
Yeah. Another thing with it is cost predictability. You know, because if you have a somebody using just a chatbot at work, what if all your employees were using the chatbot at once? You're gonna have huge amounts of cost. So that would really take that out. You won't have as many calls to other models and things like that. That would take that fear away of your cost predictability.
Yeah, that's actually very true. I didn't think about that because the companies are charging you per query typically, but you run it on your own, it's just your compute and electric bill costs. Although, if you have a lot of employees, you're gonna have to serve multiple instances of the model, which means you got to buy more GPUs. And because if I don't know what the rough estimate on how much you can serve, how many people you can serve at a time, but let's just say you have 1,000 employees, and at any given time, 40 of them are on your bot. You probably want a few instances, two or three more instances of the model running on other GPUs to be able to simultaneously serve everybody.
Yeah, there really is a good, cost benefit analysis on whether the one time cost would be worth it, or just making straight API calls. And for something like a chatbot, if you're not incredibly concerned about privacy, I would assume it would be better to go with a company like OpenAI or Anthropic, because they have the GPUs. They keep them cheap because they have all of them.
Yeah, and I mean, and the thing is, like, the privacy, they themselves, say they don't. You can select not to train on your API based data, and I believe they do that because you know, if company data got leaked to users through the chatbot training, it would be catastrophic for them. So I believe that. I guess the fear is just sending the external API calls, but then you have people like Anthropic who have partnered with AWS, and AWS runs their models on AWS system, so you can bring those models into your own gated infrastructure. So it's really only staying in. I mean, it's not in house because it's going out to AWS, but it's all in one APC basically. So there's the privacy issue. Is tenuous. It's confusing, but I guess it's always the easiest way to put it is if you run it locally, you're very private.
So we kind of talked on and touched on running your own models and how that works, how it could benefit a company. One thing that I'm really excited for and looking for GPUs for is synthetic data. The idea of synthetic data, and Nvidia has actually touched on this. They're kind of at the frontier of it with their Groot models, is what they call it. Isaac Groot, used for robots and things like that. And they've actually said that in these new manufacturing facilities, they're going to be using those frameworks and models to build robots for the facility. And what these really do, what synthetic data really is all based around the idea that real data is scarce and expensive. You know, to train a robot, it takes thousands of hours doing one specific task, so it can learn to detect objects and things like that. But with synthetic data, instead you can take that, basically a seed piece of data, whether it's video or image, and then you can using generative AI, you can generate thousands of different scenarios, so it can learn from them. And a huge advantage of this is control and diversity. So you can simulate rare or dangerous scenarios safely. So let's say you're training a self-driving car. You could have thousands upon thousands of hours of just regular driving, but how many crashes or, emergency object detections are you going to have? Those are definitely going to be a lot more rare. And so with synthetic data, you could take one of those occurrences and plug it in and then generate thousands of them. Generate me some in the snow, generate me some in the rain based off of one specific piece of seed data. And so that's one thing that I am super excited about. Imagine if you had a robot. Let's say a Roomba. You have a Roomba that goes around, sweeps up your house, vacuums the house, but it encounters an object, bounces into it, gets stuck. What if instead you had that Roomba, when it encounters that object, then understands, records it, and when it goes back into its little charging hub, it then sends that data off. That object that it encounters sends it off, runs thousands of simulations on it, so that can never happen again. And I think that's really the future of robotics, and it's going to be huge in the coming years. And I really hope to kind of get my hands on those models so I can start running them myself.
Yeah. I mean, synthetic data is already massive, even in the LLM space. What they're doing right now. I mean, what everyone assumes is they're using these reasoning models to get really nice reasoning traces. Actually, in the DeepSeek R1 paper, they show this. They use R1 to generate all this answers to these questions. It has this really nice thought out like reasoning trace, and then you can use those reasoning traces to train and fine tune much smaller models, and it like makes them much smarter. And the flow right now is you you use the reasoning traces, you save all the reasoning traces for the original model, and then you start to train a bigger non reasoning, so a GPT, essentially like a GPT model. You train a GPT 4.5 and you include those reasoning traces so it's even smarter, and then you do reinforcement learning on that base model, and you'll get another set of reasoning traces, and it just turns into a loop where they train bigger and bigger models with newer and newer reasoning traces, and it's just a massive synthetic. At some point, I mean, I'm sure it'll sort of sort of plateau, but right now it looks like no end in sight to the value of synthetic data.
Yeah, maybe. Honestly, we should probably do an episode in the future over DeepSeek and how they were trained and how all that works. I think that would be interesting.
Yeah. I mean, it's very interesting because the same philosophy can sort of be applied to many other models, especially sharing similar architecture, like the similar transformer architecture, where you could have, there's things called protein language models in biology where they can generate novel proteins. And the idea is you could have this sort of reinforcement learning, same sort of paradigm where you have set up a reward policy, and somehow you would have I'm out of my league when I try to talk about setting this reward policy, but let's just say in theory you got it all set up right. It could teach itself do reinforcement learning to generate better and more useful proteins is kind of the idea.
Yeah, that would be incredible.
It's happening now. It's definitely people are definitely working on it, but the whole synthetic data plus going back and reinforcement learning is very, very much a big deal right now.
Cool. Yeah, so I think that just about covers everything we had planned for today. If you want to call it a wrap, anything else?
Nope, I think that's it. We'll
All right.
see you next week. Hopefully there's some fun news in the next week.
Yeah. All right. Bye.